Look, here's a 3-meter high stone platform. If you want to move bricks to the top, you could simply place a wooden plank against it to create a ramp and push a wheelbarrow up. But if the platform were stacked 10 stories high, building a ramp that long would be incredibly difficult. So, being clever, you install a pulley on a beam at the top, run a rope through it, attach a basket of bricks to one end, and pull from the other. With a little effort, you can lift the bricks to the top. But pulling the rope yourself is exhausting and risky, and each load is small. It could take all day just to move a single truckload of bricks. So you take things a step further. You install a powerful electric motor at the top, build a sturdy steel car below, and connect the two with several thick steel cables. When the motor starts, it winds up the cables and smoothly lifts the car. But now the motor has to lift both the car and the full weight of the bricks, putting tremendous strain on the system and shortening the motor's lifespan. Once again, you find a smarter solution. You attach a set of cast iron counterweights to the other end of the cables. As the car rises, the counterweights descend. Like the two sides of a balance scale, they offset much of the load, so the motor only needs to overcome the difference between the weight of the cargo and the counterweight. Energy consumption drops dramatically, and the motor lasts much longer. However, there's still a problem. The car sways in the air, and even a strong gust of wind can make it wobble. To solve this, you install 4 perfectly straight steel guide rails along the side of the structure and equip the car with roller guide shoes at both the top and bottom. From that moment on, the car travels smoothly and remains stable throughout its journey. Then another question comes to mind. What happens if a cable breaks? So, being clever once again, you install a safety brake system beneath the car. At its core is a pair of wedge-shaped brake shoes that normally remain just a few millimeters away from the guide rails. At the top of the car, you add a centrifugal governor connected to the safety mechanism by an independent steel rope. If the car ever begins to fall too fast, the governor spins at high speed and instantly locks due to centrifugal force. This pulls the linkage mechanism, forcing the brake shoes into the guide rails. The harder the car tries to fall, the tighter the brakes grip. In less than half a second, the car comes to a safe stop. Congratulations, you've just invented the modern elevator. It is humanity's answer to vertical distance, transforming a 100-story climb into the press of a button. It allows seniors, children, workers, and freight to move effortlessly between floors. Today, the elevator is not only the circulatory system of modern buildings, but also one of the essential technologies that make the height and density of modern cities possible.